the small, the radius of the small this design speed, the small the horizontal radius of the curve, the minimum radius of the curve we have. Okay? So now let's continue. Look at this slide. I want you to look at it and of course try to see the components of the simple circular curve, because in the horizontal alignment we are having simple circular curves, we are having reverse curves, we are having broken back curves, we are having compound curves, we are having also sometimes like the parabola. Parabola means it's a combination of a simple curve and so that we are trying to make as simple as possible the turning. If you try to look at the this diagram on this slide, you can see you have a lot of elements on this, but the important thing here is this point of intersection, which is defined by this delta, which is the deflection angle. You can see the more the deflection angle, the more the turning becomes also a problem, because the curvature of the curve will be somehow difficult. Degree of curve, that's what we call degree of curve. Okay, so from this diagram, of course, we'll be having we're having a lot of elements which are very important for you as engineers, and those elements can be termed as this one. This is the point of intersection. Of course, this is the intersection angle. Then we have this PC. This PC is what we call point of curvature. I give you like maybe, let's say 1 minute. You just make a sketch of this one, and then I can talk of all of these elements when you have this sketch, if you can. So it will be better for you. So you can see this curve, which is starting at the point PC and is ending at PT. Where it starts, it is known as the point of curvature, and is ending at a point which is known as a point of tangency. And of course, this curve is defined by what we call degree of curve, or degree of curvature. And we have, of course, the radius of the curve that I was talking about. We have LC. LC means the distance between PC and PT. This is what we call the long chord. And then we have the mid-ordinates, M, mid-ordinates, which is, of course, from PI to this point. We have the external distance. The external distance is from here going to the point of intersection. We have also some points on the curve, here along. I'm not requesting you to memorize all these formulas here, but I want you to look on the diagram and see that each component of the horizontal curve can be computed based on the given parameters. So this is for information. And as far as the tangent distance is concerned, when talk of the tangent distance is T. The tangent distance is from PC to PI, or from PI to PT. This is what you call the tangent distance. We have what we call, for example, external distance. External distance is the distance from here, from this point here, going to going to PI. And it is, of course, given its relation. And you have the curve length. Curve length, of course, is going this way. This is L. We have also the M. Which is this mount here, from here to here, and it is known as the middle ordinates. All these elements are the elements of a horizontal curve. So what is important for you as engineers to know to be in the future is that normally for horizontal curves, the minimum radius of the curve that we can have is 14 meters. If you find somewhere that the radius of the curve is less than 14 meters, you should treat that one as a substandard. You understand? So I think you can even go back and look at these tables. So the minimum radius of the curve that we can have is 14, meaning that the design speed in that particular case, it will be 20 kilometers per hour for a super elevation of 4%. If we have a super elevation of 60%, we shall be having a minimum radius of the curve, which is 15. This is something which should be in your brain as engineers. Now, let's look again on reverse curves, broken back curves, and the compound curves. Let us start by the simple circular. No, simple circular curve, I think you have already completed. Let's go to the reverse curve. What does it mean by reverse curve? Reverse curves, of course, are curves which are made up of two different radius. And they are in the opposite direction. So the curve, reverse curves are, of course, curves which are in the opposite direction. That's the major thing. They can even have the same radius, but they are in the opposite direction. I'm going to show you the diagram. Then a broken back curve is a curve which is followed by another curve, and then it goes in the same direction. A compound curve, it means that curves are in the same direction, but at the tangent section, another curve is added, and that curve can even have different or of course different radius, and also it can even be in the opposite direction. That's a compound. Compound means a mixture. Let us try to look at them. You can see, for example, here, these are PT. You can see this curve is coming, and then here we have like a tangent section, then another curve is introduced. So if you look, you may think that this is just one curve of the same radius, but it's not the case, because we have a separate curve here. So it is broken back because it is arranged in such a way that they are running in the same direction, and This is due to the unusual topographic conditions that you can meet on the site. For example, the horizontal or curves are generally provided for the purpose of changing the direction or for the purpose of avoiding some obstacles. So it may happen that you are turning to avoid an obstacle, then you want to continue again turning, but without introducing or without, of course, disturbing the previous curve. So in that case, you will be required to make a broken back curve. It means that you have the first curve, and then another curve again will be provided, but running in the same direction. In the agreement, no, this is the yeah. In the agreement with the East African community, normally the broken back curves, the minimum radius can be, or the length of the curve can be expressed using this relation that is provided by the RTD design manual. Even if you look in the other standards, there is a minimum, what you call the minimum length of the curve. Maybe that's a new terminology that I'm going to introduce to you, because from the beginning, curves, I was telling you that it is